Welcome back everyone. Today I've got the new RSQ3 F3 with me and we're going to be talking about the intake system. Now we have already developed the RS3 intake for the 8V, which is based on the same engine. There are a few slight differences between that and the system we've made for the RSQ3. So in this video we're going to be looking at the new RSQ3 intake system that we've developed and also comparing them side by side with the stock intake. So first things first, let's have a look at the stock intake. I'm going to remove it and then we'll look at the two systems side by side. Okay, so having a look at the Dazo engine by itself, same 5-cylinder engine as the RS3 system, but in this engine bay in the RSQ3, it is slightly lower as compared to where it sits in the RS3. You can see the level of that engine cover is quite low as compared to where this front slam is. Now that obviously has an effect on the intake system positioning because the duct is a little bit higher than the airbox, so the duct sort of swoops downwards to the airbox, and then you've got this tube which also comes down after the airbox and into the turbo. So those are the slight differences between how the airbox sits in the RSQ3 as opposed to the RS3, which obviously has an effect on how we've designed the intake. That's pretty much it in terms of the macro differences between the two systems. I'm now going to remove the intake and we'll have a look at it side by side. Let's start by looking at the comparison between the stock and the Eventuri. Now we're going to go piece by piece. So the only logical way is to do it in order of how the airflow moves through the system. So the first part is the duct, which connects to the front panel and air is pulled in from the front bumper. So obviously this is a stock system. As you can see, it's got two openings on each side, and that's pretty much where the entire system draws this air in from, these two openings. They're not even fully open, so I mean, if you can see that there's an angle in there which then directs it into the duct. So you've got this is quite a small opening inside because it has to go through this small section all the way across, and then it sort of flows through here. So there's almost like a split in the middle. Now comparing that with the opening of our duct, obviously it's a lot bigger. It's all the way through. It's fully open. There's no splits in the middle or blanks as there is on the stock one. If you see them on top of each other. And the other thing that we've done is we've actually decoupled the front duct from the actual openings in the slam panel. So where this rubber strip is on our duct, this is actually a raised portion. So this lifts up and is now breathing from also behind where the bonnet closes. So we're not restricted to just those two small openings in front of the slam panel. Now, once the air goes into the front of the duct, it also has to move out and into the housing or the airbox. So on the stock one, that's where it connects into the airbox, and that's where the airbox breathes from. Now compare that with our one. See, obviously I need to talk about that difference. It's absolutely massive in comparison. So whereas this duct is quite restrictive in terms of how the airflow is having to squeeze through those openings, our one is much bigger in terms of volume and cross section. Okay, so that's the front duct section. Moving on from that, it goes into the filter, which on the stock airbox is the actual airbox itself, and our one is the filter housing. So I'll put these away and grab the airbox. Okay, so moving on to the main part of the intake, which is obviously the airbox system. Stock intake, which is obviously a cuboid airbox with a rectangular panel filter inside, and then the Eventuri filter housing, which is our patented Venturi style reverse cone filter system. Looking at the stock airbox first, so the duct which we just showed you connects to this lower section here. It actually goes inside. Airflow goes in there into the panel filter upwards by 90 degrees, so it's turn up 90 degrees to the top part of the airbox, and then again 90 degrees this way to move to the outlet, which is over here. And then there's a tube which comes off there, goes to the turbo inlet. Now, as you can see, the filter inside. That's just straightforward rectangular panel filter. And obviously, being a cuboid box, it's going to have corners, and those are not very good when it comes to airflow. So you can have natural voids where the corners are and turbulence, and the entire section of that filter won't be efficiently used just due to the natural path of the airflow. Let's compare that with the Eventuri. So the duct sits on this face, so it goes straight into that filter. There is no turn or flow like there is in the stock airbox, so it goes straight into the filter and then straight out, and then it negotiates around the filter through that Venturi section, which smoothly tapers down in terms of cross-sectional area to the outlet, which is 4 inches to our tube. So it's very direct, very straight. The airflow is much smoother. There are no corners like there are in the stock airbox for turbulence to develop, which means that the turbo is able to draw air in more efficiently. There's less overall drag in the system, and then it comes out from that area. So let's show you the difference in size. Now, this is a bit deceptive because the actual area is on the inside compared to that one. So there is a big difference in cross-sectional area even on the outlet. Okay, so the final components of the intake systems are the tubes. So the air's now gone through the filter's kind of smoothing the airflow out a little bit, and it now goes into the tubes. So the stock tube comes in from this end, which is where it connects to the stock airbox, travels through this flexible section, and then through this solid tube, which directly connects onto the stock turbo inlet. The diameter at this end is 72 millimeters on the inside, which is about 2.8 inches in diameter. Now, let's compare that with the Venturi tube, which is here. Pre-preg carbon fiber, all one piece, so there are no flexible sections, which is better for keeping the airflow smooth. So this end connects to the filter, the filter housing, and airflow then travels through that section, and then on this side we connect this to a reducer, which is this one, and that reducer directly connects to the stock turbo inlet, which is obviously the same diameter as a stock diameter. So we're keeping the diameter as big as possible, as far as we can, up to the inlet, and then it smoothly tapers down to the same size as the stock inlet. So before it tapers down, this diameter is 4 inches, which is about 102 millimeters on the ID. So if you compare the two diameters, you can see there's quite a big difference there, which obviously just helps to de-restrict that flow path to the turbo as far as we can before it has to neck down to mate onto the stock turbo inlet. Now, we do make our own upgraded turbo inlet, which is also 4 inches. That comes with its own silicon coupler, so there's no reduction in cross-sectional area. That directly mates onto the 4-inch turbo inlet, which then smoothly tapers down to the stock turbo inlet, which again de-restricts it even further. So I've got the entire RSQ3 system laid out in the table in front of me. We've seen the main components. Some of the smaller components you haven't seen are like some of these custom silicon breather tubes. We've got additional brackets. Also, we have a heat shield, which is lined with a reflective material, and that sits directly over the exhaust manifold to minimize heat transfer into the tube. The principles and the airflow path that we spoke about in comparison with the stock system previously also applies to the RS3 and the TCRS system. They're both exactly the same. Only difference is the shape of this tube and some of these brackets. So the principle in theory applies exactly the same between the RSQ3 system and the RS3 and TTRS intake systems. So that's the entire system. I'm now going to install the intake into the car, and then we'll show you what it looks like in the engine bay. Okay, now we've installed the RSQ3 intake system. Let's have a closer look at how it looks like in the engine bay. Obviously, first thing to notice as compared to the RS3 is the intake sits higher than the engine itself. That's because of the extra space in the engine bay and the height of it. Now, as we mentioned earlier, you can see this opening in the duct now. So that's now decoupled from the small openings in the actual slam panel. So this sits just behind the closing of the bonnet. So you've got this extra area where the intake can breathe from. Airflow then smoothly goes into this opening of the filter system, which is our Venturi housing, straight in through the housing and then connecting to the back tube, which then goes nicely into the turbo inlet. So you can see we've kept that diameter as large as possible all the way through, and then you've got a reducer just before the turbo inlet itself to kind of just de-restrict the turbo and make it easier for it to breathe. That's pretty much it, really. It's a very direct system. It's obviously much more smooth in terms of airflow path as compared to the stock system, which had a few 90-degree turns up through the panel filter and then through the top of the airbox into that tube, which allows the car to breathe more efficiently. It allows the turbo to spool up quicker, less the wastegate duty cycle is less, as we've seen on the RS3 system. All in all, it gives the engine a better performance as we've measured on the RS3. We will be doing some performance testing on the RSQ3, but for now we believe that the testing we did in the RS3 is transferable to this engine because it's the same.
Thank you so much for watching, guys. If you liked the video, please give us a thumbs up, and if you haven't already, please remember to subscribe to the channel and turn your notifications on. If you want to join the conversation, please drop us a comment below and we will do our best to respond to you. And if you're running out of things to watch, why don't you watch one of these two?